Hi, a little while ago I came across these. These are fairly commonly available sort of pseudo filament lamps. They're actually based on these strips which comprise a number of blue LEDs on a metal strip with a white phosphor. So they basically give you the effect of a very similar effect to an incandescent filament, but with the efficiency of LEDs. And they do quite a passable attempt at looking like a filament lamp, and they're available in all sorts of different shapes and sizes. So the supply and the base of these is very similar. It's just a capacitive voltage drop with bridge rectifier and some resistors. That's all it is. So the nice thing is, because the actual current through the LEDs is quite low, you can use a really simple supply with these. And also, you're running on main voltage. You're working from a fairly high voltage to start with, and also mean you don't have the complexity of a sort of a high current converter, which you'd have to have if you used relatively few LEDs in here at a high current. So it sort of solves a couple of problems in one go, really. So it keeps it simple, no electrolytic caps, to produce sort of something that looks like quite a nice sort of filament bulb. So I didn't really think that much about these at the time, but then a little bit later I came across a video on Big Clive's YouTube channel saying that you can actually get these filaments separately from eBay, and they're cheap. They're like sort of 60 odd p or something each, or even less if you buy a quantity of them. I got hold of a few of these, and basically what they are, they're a flat metal strip with a number of individual LED die wired in series on the strip. These ones are 28 LEDs in series. And if I run this strip at very low power, you can actually see the individual LEDs quite nicely. And the ones in this lamp have some sort of resin coating, whereas these ones are actually the lead phosphor is like a silicone sleeve. So one nice thing about these silicone ones, you can actually bend them to some extent, but you do have to be a bit careful, because at some point they do break. So sort of a smooth curve is okay, but anything vaguely sharp, they go intermittent, because it breaks the bond wires. And if you bend them with the LEDs inwards, if you bend them with the LEDs pointing inwards, they're a little bit more resilient, because you're not stretching the bond wire. But if they're bending the other way, they snap quite readily. And one word of warning, if you're ordering these, I've done a couple of orders, and both of them, they've just thrown them into a jiffy bag with no extra protection. So if you need a certain number of good ones, order plenty of spares, because I've had a few that have come a bit bent, and the odd one that wasn't working. So they're not the best in packaging. Just be aware that you might not get as many useful ones as you think you ordered. Now, because these LEDs are connected in series, they do need a moderately high voltage. Their forward voltage is of the order of 70 volts for these ones, at a current of around sort of 10 to 15 milliamps at full rating. So the rating of each one is approximately 1 watt. And of course, because the LEDs are spread out, you don't have the same power dissipation issues that you have with the single die high power LEDs, of having to get the heat out and having to mount them on an aluminium PCB, because these have got a fairly big surface area. They can sort of dissipate the heat quite nicely. Now, I said these are normally rated to run up to about 15 milliamps or so. I suppose it will be interesting to see what happens if we go above that. So I've just hooked this one to a variable bench supply with a 1k resistor, just has some current emitting. So let's just see how far we can crank this up. Still going at 30 milliamps. Obviously most LEDs get less efficient at high current, so if you double the current you don't necessarily get twice as much light out. And if you go way high, then they turn into dark emitting guys. Oh, we've got some smoke, and it's sort of turning a bit almost greenish. Oh, and it's gone. Oh, gone into me. Oh, it's flashing. You've got a little thermostatic effect there. So it's cooling down, making contact, heating up and going out again. So at that level it's actually so I'm not touching the voltage at all, I'm just leaving it, and it's gone into its own little thermostatic loop. Let's crank the voltage up a bit more, see what happens. Yeah, we see there's some LEDs that are going. We've got some general burning and unwellness. And if we take it back down, so we can see a number of LEDs have failed short, and those will probably gradually carry on fading one by one. Now, when I started playing with these things, I was sort of thinking about what sort of things might be interesting to build with them. I was reminded of these. This is an old display technology, sort of the predated LEDs. It was around about the same sort of time as Nixie tubes, which basically used filaments as display segments. These were quite commonly used in things like petrol pumps. And you get this nice, because of the obviously the heat of the filament, they're spaced off the back a little bit, so you get quite a nice sort of 3D display with a sort of nice reflection off the back, and sort of a nice sort of wide viewing angle, and of course a nice sort of valve type appearance. These ones are called pneumatrons. There's another similar device around at the same time called a minitron. This is actually a Japanese version of a minitron, which looks slightly different. I don't have one of the original ones. And these work on a similar principle. Again, it's just sort of basically a box with the filaments stretched out. The original minitrons look more like just a black box with the filaments, but again you get this nice sort of 3D filament effect. So I thought it'd be quite fun to sort of emulate this display using these filament displays. I thought it might be quite nice to emulate these displays using these LED filaments instead of real filaments. So I had a thought about, did some thinking about how to mount these now. You could actually just mount these on a PCB. These ends are solderable. You could just bend these tabs down and solder them down, but that wouldn't give you the 3D effect. So I was sort of doing a bit of experimenting. I came up with this. These are turn pin wire wrap sockets. For those of you too young to remember wire wrapping, it's basically a prototyping system where you had IC sockets with very long pins, and then you used a special tool to wrap wire around it to provide to avoid having to solder it. It's not really used these days, but you can still get the socket. These are basically the individual socket pins used in these IC sockets. So I did this prototype just to get a feel for sort of what it looked like. And one issue, of course, is there's a risk of shorting between these pins if you just take the pins out, and it can be quite hard to actually get these vertically. I wanted to use a single-sided board so that I could experiment with like different coatings or textures on the front face, and also if I ended up just using, say, a black solder resist or something, I didn't want to have any tracks on it, and also I wanted to do a homebrew board rather than getting a professionally made one. So it turns out it's actually quite hard to get these dead vertical, and so shorting is a major issue. So what I did, I used this. This is basically the same thing, but it's a single inline strip, and you can snap it apart, so you can very easily sort of snap these into a pair like that, which you can then use on the corners, and obviously on these centre bits you use a pair and then a single one. But again, you don't have that issue of shorting, and it maintains the spacing quite nicely. And if you fold the pins flat at right angles, these do plug into the sockets reasonably well. Obviously you could solder them as well. It's just that the nice thing about this is you can get them in and out. I think long term, once you've got it all together, you probably want to solder them, because they do occasionally pop out because there isn't a huge amount of insertion depth in the socket. A couple of minor things you need to be aware of in sort of using these as a display. One is the polarity. Now these ones came with like a red mark on one side. I've also seen some that actually come complete with a lead frame, and the lead frame will give you an indication as to what the polarity is. But obviously that's something you need to make sure of. The other thing you need to be aware of is, because there's a gap in the strip, that's at one end, so you'll tend to find that one end is slightly, the unlit part is a bit longer than the other. That also tells you the polarity. And the other thing is, because the LEDs are on one side, the visual appearance is slightly different between one side and the other, so you need to make sure you mount them all the same way up. So if that's the LED side, as you sort of look from the back, you get more of the diffused light from the sort of through the phosphor coating. It's a bit hard to see on camera, but there is a very noticeable difference in appearance from one side to the other. Mostly difference in brightness in practice. Now obviously one issue because these need 70 volts is how you drive them. Now in the context of a display, you can way underrun them. So normally in the bulb they run at 10 to 15 milliamps. In practice I found for a display you only need like 1 or 2 milliamps at the absolute most. to get decent brightness. Anything else is just ridiculously bright, and if you want to have make a sunlight readable display, then yes, you could run at full power. So obviously you need a fairly high voltage power supply. There isn't really any getting away from that. But in terms of actually switching them, now one option is just to use a simple transistor switch. Transistors, for example, like the MPSA 42 are quite common for Nixie projects. But a while ago I was actually doing another project. I came across these Texas Instruments drivers, the TPIC 6B595. These are basically like 74HE595 shift latch registers with open drain outputs. And the nice thing about these is they'll tolerate up to 50 volts on their output. Although we're using a 75 volt supply, we don't actually need to be able to switch that because the LED itself is dropping about 70 odd volts. If we let's say for example we start off with 75 volts, we have a series current limiting resistor. Because we've got about 70 volt drop across here, we're only actually switching about 5 volts. So it means that with these drivers, because these drivers will tolerate up to 50 volts, our supply can be anything from like 70 up to well over 100 volts, and the driver will still be happy and it won't start conducting when it's supposed to be off. So this provides a nice solution for switching 8 of these filaments very easily from a simple SPI data stream. So having figured out the rough method, what do we build with it? Well, the obvious thing, a clock. So this is a fairly quick thing I knocked up, sort of really simple construction. Again, using these wire wrap sockets, and all it is, it's 3 of these TPIC 6B595 drivers, a little 14 pin PIC with a 32 kHz oscillator, and a boost up power supply. This runs off 12 volts, and there's a UC3843 base power supply to boost up to provide 75 volts. And the nice thing about that particular tube is it's got a 5 volt reference output, and that can actually supply enough current to run the PIC and everything, so that actually provides our 5 volt supply as well. It's not ideal for running the LEDs. These LEDs are being run at about 1 milliamp or so, and for that it's just about okay. The problem is if you crank it up too much, it's not particularly efficient and it starts getting a bit hot. Above a certain level you start seeing sort of the current rise sort of very slowly as things get hot, so it isn't ideal, but it was just basically a quick and dirty thing that I built out of stuff that I had to hand, and also something that's fairly easy to do on a single layer PCB. If you want to build this, if you look at the link on the bottom, there's an info page with PCB layout, schematic and stuff, and there's quite a lot of scope for improvement on this. For example, there's no battery backup for the time, but you could easily add that just with a battery or super cap. And probably the main thing I don't particularly like, I think the digits are a little bit too close together. Close up it's actually a little bit difficult to read. One reason I think the digits are maybe a bit close together, but also the contrast, even the off segments are quite noticeable. I think it's partly the yellow colour, but also they're catching some light from the adjacent segments that make them glow a little bit. And I think it probably needs a bit of experimentation with things like sort of tints, tinted diffusers, or possibly combination of perhaps some tints and some sort of diffusing type material. But say this is, even at low current, you can read this from a very long distance away, and if you really cranked it up, you could read it from miles away. The other thing, because you've got this bright light source on the clear front, dust is very, very noticeable. So I think you'd have to sort of make a sealed enclosure. I was just going to put some sort of flat sheets of black plastic over this and just a rear sheet or something to cover it up. But say even a small, I've actually cleaned this and you can still see quite a lot of dust. So if you just left it like that, you'd get the heat from the filaments, which isn't particularly great, but you would get airflow through and you'd end up, this thing would just be covered in dust and it would be very noticeable. Obviously you could also experiment with coloured tints as well to get certain colours. So I think it's got potential for quite a nice sort of very, very readable display. And I say you do get this same sort of 3D effect. You can see the reflection. I sprayed this matte black, but obviously you could experiment with different effects like maybe mirror finish, or even a like an infinity effect. If you had like a rear mirrored finish and a semi-silvered front, you could get quite a nice sort of infinity effect. I'm not planning to develop this or do a kit or anything like that, so the design's there. If you want to play with it, feel free, but so you're on your own. I think these things do have some potential. Obviously you could wire, for making longer segments, you'd probably need to wire them in parallel, because if you wire them in series you end up needing a fairly ridiculous drive voltage. It'd be nice to get sort of EL wire that was this bright, but I don't think we're going to see these in significantly longer segments, unfortunately. So I think there's potential you could probably do some quite nice sort of bar graph type things if you just had a sort of stack of these, or maybe some sort of radial type thing. But so they're sort of super bright and nice and cheap. And if you want to get really adventurous, you might want to think about some 3D structures.